here. So, fifth question. So, a string of negligible mass going over a clamped pulley of mass m supports a block of mass capital M as shown in the figure. Then, what is the force on the pulley by the clamp? Are you able to understand? Ma? So, clamp will give how much force on the pulley? That is the question. See, ma, here, first of all, why clamp will give force on the pulley? Can you say? Which is meant by clamp here? This is the clamp. No? This is called as clamp. Clear? Ma? So, the clamp will give force on the pulley. Can you say? Hmm? Why this one will give force on the? No, it is not because of rotation. See here, this mass of capital M, it is in rest position. No? Capital M is in rest position. No? Are you able to understand? Why it is in rest position? Why capital M is in rest position? Because here there should have been some tension, which is balancing this weight mg. So weight mg of this block is acting in which direction? Weight capital mg is acting in downwards direction. No? Clear? No? So therefore, can I say T must be equal to mg? Can I say T and mg they must be equal? No? Are you able to understand? Okay. Now same tension, what it is doing on the pulley? It is pulling the pulley downwards. No? Are you able to understand? One tension, it pulling capital mg in upward direction, but the same tension is pulling the pulley downwards also. Correct or no? Okay. Similarly, same tension is pulling this wall in this direction. No? Same tension is pulling the wall in towards right side, and again same tension, it is pulling the pulley in this direction. Because already we discussed that what will be the direction of tension? Direction of tension, it will be away from the side end. Are you able to understand? So therefore, on the pulley, so totally how many tensions are acting? Two tensions are acting. That's all. Okay. I don't know. Clear now? So therefore, if you see this pulley, this is one tension which is pulling the pulley downwards, and this is another tension which is pulling the pulley towards the side. Are you able to understand? And what is T here? T is nothing but a capital mg. T is equal to capital mg. So can you take the resultant of these two forces? What is the resultant of these two forces? Say, resultant of these two forces is this much. This is by using which rule of addition? Parallelogram rule of addition. Two vectors are joined into tail. So resultant is let it be. So therefore, can I write f is equals to square root of t square plus t square? Can I write like this? Because there a rectangle triangle is created. If this is t, this is also t. So therefore, f is equal to square root of t square plus t square. So t square plus t square means how much? So f I can write it is equal to square root of t value is how much more? Mg. So mg whole square plus mg whole square. So this is the resultant force which is acting on the pulley. Is it clear? Are you able to understand? Clear number? Then pulley is also having some weight. No? Pulley is also having some weight. Weight of the pulley is acting in which direction? Weight of the pulley is acting in downwards direction. And what is the weight of mass of the pulley? Mass small m or capital M? Mass of the pulley is small m. So small mg is acting in downwards direction. Are you able to understand? So therefore, totally how many forces are acting? Totally how many forces are acting? One force is this F and another force is F. So these many forces are acting on the what you call pulley. Are you able to understand? So this pulley is attached to what? This pulley is attached to clamp. Pulley is again attached to clamp. Okay, so pulley will exert a force on the clamp. Then by Newton's third law, what will happen? By Newton's third law, clamp also will apply force on the pulley. So sum of all these forces is nothing but the force applied by the pulley on the clamp, and that is again equal to force applied by the clamp on the pulley. Are you able to understand now? Understood now totally how many forces are acting here? So that is the method in which we are supposed to solve this problem. Is it clear, ma? That's it. Okay. So next to see question number 6. So the pulleys and the strings shown in the figure are both under negligible mass. So for the system to remain in equilibrium, find the we present. See ma here, totally how many masses are present? So this is one mass small m, this is another mass small m, and this is the mass root 2 m. Okay. So if I'm releasing this system, total system is present at rest position. Then what is this angle theta that I am supposed to calculate? Theta value I am supposed to calculate. Able to understand? So in which condition a system can be in rest position? System can be at rest position in which condition? System can be in rest position if all the forces if they are balanced. That's all. If all the forces if they are balanced, then system will be in rest position. So let us see what are the different forces which are making the system to be in rest position. Clear number? See here. So if you take the weight of this body small mg is acting downwards. Are you able to understand? And one more force T should be present here. Can you what is the relation between T and mg? T must be to m. How can you say T and mg they are equal? Because they are at rest position. No? So definitely T and mg they should be equal. Clear? Here also same tension T should be acting. Are you able to understand? So here also I can say T is equal to mg. Now can you say here how much will be the tension and here how much will be the tension? There also T and T only. No? Are you able to understand? But this T, I will try to split into two components. Which T, this T I am talking about and this. So this one if I split into two components, are you able to understand? So this is T cos theta and this one is T sin theta. Similarly, there is one more tension number. That tension also I will split into two components. This is T cos theta. This is T sin theta. Now, this root 2 mg should have been balanced by which forces? Balances root 2 mg. Root 2 mg is nothing but weight of the block. No? Who is balancing that? Can you say? Huh? T. 2t theta is balancing. 2t cos theta is balancing. Tima, this t cos theta and this cos theta, they are acting in upward direction. What are the which are upward direction? T cos theta, two forces which are acting in upward direction. So 2t cos theta must be balancing weight of the body. What is the weight of the body? Root 2 mg. Clear now? So therefore, from here I can do the calculation. How can I do? Let us. So I will do here. So 2t cos theta should be balancing root 2 mg. And what is t value? T value already we have calculated. T is equal to mg normal. So substitute there. So 2 into mg cos theta is equal to root 2 mg. So mg get cancelled. So therefore cos theta is equals to root 2 divided by 2. It is 1 by root. So theta is 1 by root 2. Then what is theta value? Cos theta if it's 1 by root 2. Theta value 45 degrees. So that is my answer. Okay. So system to be in rest position. Angle should be 45. But to understand how we are solving, system can be at rest position only when net force becomes zero. Net force is zero means what? All the upward forces and downward forces they are getting balanced with each other, are getting cancelled with each other. That's all very simple. Is it? That's it. Okay. Similarly, now let us see this question which we can solve with the help of constraint motion. Seventh question. Okay, so in the element shown in the figure, the ends P and Q on unstretchable string move downwards with uniform speed U. So pulleys A and B they are fixed. Mass M moves upwards with how much velocity? Are you able to understand, ma? See, ma, consider here there is one block. Consider here also there is one. There are no blocks actually. We are considering. Consider this is block A and this is block B. Blocks they are moving downwards with how much velocity? They are moving downwards with how much velocity? I'm already given. No, they are moving downwards with the velocity of u. This is also moving with the velocity of u. This is also moving with the velocity of u. Are you able to understand? Okay. Then, if both these blocks, if they are going downwards, then mass capital M will move upwards with a particular velocity. So let that velocity be. How much I will call that velocity? Let that velocity be v. And exactly this v value only we are supposed to calculate. Are you able to understand? Now, okay, you say how can I calculate the velocity v? Can you by method can I do this calculation? Summation of TV cos theta. So you want to do by virtual work method. Definitely we can do by virtual work method. And I can also do this calculation by using the method of. By using point method also we can do the calculation. What is meant by point method? Identify the points. So this is point number one. Clear? Point number one, point number two, point number three, point number four, point number five, point number six, point number seven, point number eight. Totally how many points? 8 points are. So if you add the velocities of all these points, total should be how much? Total should be. It's called as point method. No? Understand? No? So if you add the velocities of all of them, total velocity should be equal to 0. Okay. Now can you say what is the velocity of the point? No? Velocity of first point. Velocity of first point. U plus U or minus U? Plus U plus because first point is going downwards. If first point goes downwards, what happens to this string? Sorry, what happens to the length of the string? String increases. If length increases, its velocity should be positive. Are you able to understand? So I will write plus u. Clear number? Then the velocity of point 2 and p, they are 0. Why they are 0? Because they are present on a fixed pulley. Pulley cannot move. So also cannot move. Okay. Then what about velocity of point number 4, point number 5? You know those velocities? Vector I can split in two components. So this angle theta is already given now. So V cos theta and this is V sin. Now can you know what is V cos theta? V cos theta is the velocity of the block in the direction of the rope. And I am supposed to take all velocities in the direction of the rope only. Are you able to understand? So what is the velocity of the block in the direction of the rope? V cos theta. Now can you say it is plus V cos theta or minus V cos theta? Minus V cos theta. Why minus V cos theta? Because the length of this is, it reduces of that particular one block. So negative. So therefore I will write speed. Then what about step number 5? 2 points there. The rope number 1, both of them they are in the block upwards. So it is equivalent to 2 points present. Point 5 4 is also present. 5 is also present. Now what is velocity of point number 5? I can say minus the velocity of point number 7, point number 7, 0. Why they are 0? Because they are present on fixed point. Velocity of point number 8, u plus u. Why plus u? Length of this rope increase. Clear number? Plus u. Total should be equal to u. That's all. Very simple. So you take the velocities of all the points which are present in the rope. Velocity should be which direction? In the direction. Okay. Add all the velocities. Total will be equal to 0. Clear number? Now do the calculation. Now you can do from here, no? Or let us do. So 2u is equals to 2v cos theta. So 2 get cancelled. I am supposed to calculate v only, no? So u cos theta. So this is the velocity. So very simple. Hmm? 2u by cos theta. This is the answer. Okay, ma? Maybe he should have solved a bit differently. Understood, Amma, how we have solved? That's it. Okay. Now, see this sixth question. Sixth question, see. So when forces F1, F2, F3 are acting on a particle of mass m, such that F2 and F3 are mutually perpendicular. So consider this is a block. Okay, ma? So this is a force F2 and this is our force F3. So they're acting at an angle of 90 degrees. Are you able to understand? And there is one more force also. That force is what? This force is F1. And F1, F2 and F3, they are mutually, F2 and F3 are mutually perpendicular and they are keeping the body stationary. What is meant by they are keeping the body stationary? No. Sum of all these forces is 0. That is the meaning of keeping the body in equilibrium. Clear now? It means all the net forces acting on the system is how much? Sum of all the net forces is 0. That is called as keeping the body in equilibrium. Able to understand? Okay. Now the question is, if force F1 is removed, if I remove force F1, then what will be the acceleration of the particle? That is the question. Can you see? Very simply we can say. Without any calculation, you can say the answer. Hmm? Acceleration is F1 divided by mass of the particle given now. What is the mass of the particle now? He did not give anything. Let us assume A is equals to F1 by M is the answer. Can you say this is 1 by M? Imagine the resultant of F2 and F2. If you take the resultant of F2 and F3, they are perpendicular now. Able to understand now? The resultant will be in this direction. This is the resultant two forces. Yeah. So this resultant of F2 and F3 is balanced by whom? It is balanced by F1. Are you able to understand? So if you remove F1, then you are removing the balancing force. No? You are removing the balancing force. If you remove the balancing force, remaining force will become unbalanced force. No? And that unbalanced force you can take either this one or this one. Both are equal. Are you able to understand, ma? So what is the magnitude of this force? Magnitude of this force is also F1 only. That is why they are getting balanced with each other. No? Are you able to understand? So if you remove one force, then what is the remaining force? F1. So acceleration should be produced by unbalanced force only. So A is equals to F1 by. Are you able to understand what doing calculation? So the resultant of F2 and F3, that is nothing but F1. That is why this F1 was balancing this F1. Are you able to understand? Once you remove one Fm, other F1 is already present. So that will produce the acceleration. Fine, no? That is how we can do this problem. Very simple. Okay. So next let us see fourth one. So a particle of mass 0.3 kg is subjected to a force of F is equals to minus kx, where k is equals to 50 Newton per meter. So this is question based on slightly simple harmonic motion also, but you can study in what called Newton's laws also. So what will be its initial acceleration if it is released from a point 20 centimeter from the origin? Clear, ma? See, ma, this F is called FR, restoring force. This K is called spring constant. This is not relevant to question, ma, but still I am explaining. Some persons have removed. X is nothing but displacement from mean position. Displacement from mean position. Are you able to understand? And this restoring force is equal to minus kx. This becomes the net force also, and net force is nothing but to action. For any body performing motion, FR becomes the restoring. Are you able to understand? And restoring force nothing but net force. Net force the mass into acceleration. What is meant by restoring motion? Clear, ma? Now, so therefore, K value is how much? 50. And what is the displacement from the mean position? Displacement from the mean position is 20 centimeter. So 20 divided by 100, because it is given in centimeters. No? This is equal to mass into acceleration. What is the mass of the body? 0.3 kg. So I will write 30 divided by 100. And what is the acceleration? It is what supposed to calculate. So 100 get cancelled, 0 also get cancelled. So acceleration is how much one? So 3 1s are 3 5s are. So acceleration is minus 10 meter per second square. So this is my answer. Minus 10 indicates that the body is moving towards the mean position. What does minus indicate? It's the body moving towards the mean position. This is how we are supposed to do this calculation. Fine? That's it. Okay, ma? So let's go to the second page. So this question already we have done. Don't think 16th problem. This one. No? Okay. No need of doing this one. Next. Question number 70. 7 here question is jump machine. No? Okay. Two masses 5k and 4.8 k spring passing through a friction pulley. So this is of machine, output machine. Clear now? So what is the acceleration of the masses? So what is the equation of acceleration in the case of output machine? A is equals to m2 minus m1 divided by m1 plus m2 into g. So just substitute here, you will get the answer. Fine?